This is part 2 for the review of Chapter 12 for Lehmann's text, Intermediate Algebra for Math 120 at Kenyatta College. Problem number 4 here, we're adding and subtracting rational expressions. We're going to add and simplify as needed. So I'm going to take this rational expression and I'm going to first of all take a look at the denominators and see that they're not alike. So what I need to do is I need to factor each of them. So I'm going to say that this is x minus 4 in the numerator, copying that down, and I would need the factors of 6 that sum to 5. Well, that would be 3 and 4. So x plus 3, 3 and 4, 3 and 2, x plus 3, and x plus 2. And then we have plus, and then we're going to look at this one. I need the factors of 3 that sum to 4. So that would be x plus 1 and x plus 3. I just copy the numerators up here. So x plus 3 and x plus 1, that's factors that give me a sum of 4 and a product of 3. So now I need to find the least common denominator here. So my least common denominator is going to have all the unique factors I see up here. I see x plus 3's, and I see x plus 2's, and I see x plus 1's. And on every single one of those factors, I see no more than a first power. So every one of these have a first power. So every single one in the least common denominator has a single power. Now what I'm going to do is I'm going to build the higher term. So I ask myself what's missing from this current denominator to give me this one. And obviously it's the x plus 1. So I'm going to multiply both the top and the bottom by x minus 1. Sorry, not x minus 1, x plus 1. All right, and so that's going to give me a product here, and I'm going to go ahead and multiply that out. So multiplying out a binomial, x and x is going to square, and the outside and the inside terms are going to add. So I have a positive 1 and a negative 4, and so that's going to give me a negative 3x, and then a negative 4 times a positive 1 is going to give me a negative 4. And this is all over my least common denominator. And I don't want to write that down for a couple of reasons. Number one, it's a lot of writing. And number two, it saves me from trying to cancel things when I really shouldn't. Now I'm going to focus my energy on the second term in this sum. And I'm going to see that I already have x plus 3 and x plus 1. That's this one and this one. So I need an x plus 2. So I'm going to multiply both the top and the bottom by x plus 2. And that'll give me my LCD. So again, I need to multiply this up here. So I get x times 5x, which is 5x squared. And then outside, I'm going to get a product of 10. And inside, I'm going to get a product of 6. And they're both positive, so it's going to give me plus a 16x. And then finally, I'm going to multiply 6 and 2 and get 12. So there's my new numerator. And again, I'm going to just write that over LCD. Now, I'm adding these. They both have common denominators. When I have fractions with common denominators, I'm allowed to just add the numerators. So now I'm going to apply adding these numerators. I'm going to apply adding algebraic expressions or adding polynomials. So the x squared terms I'm going to add together, giving me 6x squared. And then I'm going to add the x terms. So I have 16 minus 3, which is positive 13x. And then I'm going to add the constants here. So 12 minus 4, which is positive 8. And then this is all over my LCD. Now, before I write my LCD, I'm going to check to see if this factors. So remember, I have a little trick that I use, factoring by grouping trick, and here's how it goes again. It's multiply the first terms and the last terms, the constant and the x squared terms, coefficients, and I get 48. And then from 48, I want its factors, 1 times 48, and 2 times 24, and 3 times 16, and 4 times 12, and 5, no, 6, obviously, 6 and 8. And then I'm looking for those that sum to 13. So I would look along here and I would say, okay, 1 and 48, no, 24 and 2, no, 3 and 16, no, 4 and 12, no, and then 6 and 8, no. And so none of them are going to sum to 8. There's a sum to 13. There's a difference of 13, but that's different because notice this one right here, plus 8, that tells me they have to sum. And none of these sum, so this is not going to be factorable. So all I'm going to do is I'm going to come back over here and I'm going to bring in my LCD. So my LCD is x plus 3 and x plus 2. And x plus 1. Now I could certainly multiply that all out, and a lot of times that's what you'll be asked to do, but not for me. I don't require that. If I want you to multiply out some polynomials, I'll have you do it. So there we go. That's the final answer. All right, moving along to our second one, which is a difference. So in this difference, we're not going to take any different strategy. We're going to find the factors of the denominators so we can find the least common denominator. So in factoring this one, I'm going to have a y that comes out, which is going to leave me with a y squared minus 16. And when I do that, I might notice that this y and that y cancel. It's okay to cancel those. And over here, I'm going to notice that this factors is y times y minus 4. And again, I might notice that that'll cancel. And it's okay to notice that and cancel them out. Now I need to find this least common denominator. But before I can do that, I need to notice also that y squared minus 16 factors. I got a little distracted on that. So y squared minus 16 is the difference of two perfect squares, and that comes from the product of conjugates. So I need the root of the y squared, which is y, and the root of the 16, which is 4, and I create the sum and the difference of those terms. Those are called conjugates. So now I need the least common denominator from these two, and that is the product of conjugates. It is y minus 4 times y plus 4. So there's not going to be anything that happens in my first term in order to build this higher term. So my first term is going to look like 8y over that LCD. Now in my second one, I do have to do some work here. And so I need to multiply this second term, top and bottom, by y plus, not plus 3, y plus 4, because y plus 4 is my other product in the conjugate, so other factor in the conjugate. And this one, y minus 4, I already have, so I need y plus 4. So y plus 4, and remember we need to multiply this out, so I can take this negative 4 and I can distribute it through here so that I can have now addition. So I'll have a negative 4y minus 16, and that's all over my LCD. Oops, I meant to write that backwards. So LCD. And then I need to add the numerators. So 8y minus 4y is 4y, and then minus 16. And this I notice is going to factor, so I'm just going to write LCD again, and then I'm going to factor it. So 4 comes out, both of the factors, leaving me with a 4 in the first factor, or a y in the first factor, minus a 4 in the last factor. So that came from 4y divided by 4, which is y, and 16 divided by 4, which is 4. Now I'm going to bring in my LCD again. There's my LCD. So it is y plus 4 and y minus 4. And now I get to simplify. I get to apply my simplifying algebraic or rational expressions again. Y minus 4 and y minus 4 in common, so I cancel them. And I rewrite. My numerator looks like 4, my denominator looks like y plus 4, One more time, remember you cannot cancel in addition, so nothing happens with those, and that's your final answer. All right, moving on to problem number 5. We're going to simplify this rational expression. Or simplify this quotient of rational expressions. It's a division problem. Same as we did when we just simplify. Besides, we have to apply how do you divide fractions. We need to factor. So I need the factors of 3 that sum to 4. So that would be a 3 and a 1. Since that's the only way 3 factors, it's kind of nice. And I notice that my middle term is negative because it's a sum. That tells me that both of these factors must be negative. Going on to this next one, I see 18 and I need a difference of factors. So the factors of 18 that give me a difference of 3. I think to myself, well, that would be 6 and 3. 6 and 3 differ in 3 and multiply to give me 18. So I'm going to need a y with a 6 and a y with a 3. Now I need to decide which signs are appropriate to go in there. Because it was a difference, I get one of each sign, and the middle term tells me this time that the plus sign will go with the 6 because it's bigger. So a positive 6 minus 3 is going to give me a positive 3. Now I'm going to multiply by the reciprocal of this, so I need to make sure that this happens. So down in the denominator, I'm going to put the factors in the numerator. I notice the numerator is a binomial. It's a difference. That's a square. That's a square. So I need the product of conjugates. The square root of the first term is y. The square root of the second term is 1. And so I need 2 factors with y and a 1, 1 with the minus, 1 with the plus. Order doesn't matter there either way. Now the bottom is going to become my new top. So I need the factors of 24 that sum to 10. And the ones that spring to mind that do that are 6 and 4. 6 times 4 is equal to 24, and 6 plus 4 gives me 10. And the reason I know it's plus is because this is a plus, so that tells me the signs must both be the same to multiply, and therefore when they add, they'll be adding together. So I'll need a y with a 6, and I'll need a y with a 4. Last thing that I put into place is that this is a plus, so that means both of these must be pluses. Now it's time to cancel. So I'm going to look across. Y minus 3. Oh, that goes with that y minus 3. Y minus 1. Oh, one of those for one of those. Y plus 6. Oh, one of those with one of those. And y plus 4. Nope, none left in the denominator. So I'll simply rewrite what's left. Y plus 4 over y plus 1. Now remember, there's no further canceling. This is an addition problem. You can't cancel that and that. You are finished. All right, moving on to problem number 6. We're going to be solving rational expressions here. So solving a rational expression, the first thing that we want to do is get our restrictions out of the way. So this is the restrictions on the domain. So this is where the denominator is equal to 0, because if we were to get that answer, we wouldn't be able to have that answer. So we want to know what that is right up front, because our brain tends to forget about it. You can do it later. You can check your answers. There's all kinds of ways to do this, but my recommendation to my students is that we do it up front. So we get a restricted value that x cannot be equal to a positive 4. This 2 isn't a restriction because there's no variable in it. It's always going to stay 2. All right, so moving on, we now need to clear this equation of fractions. So my LCD is going to be 2 times x minus 4, because those are all my denominators. So x minus 4. And now we're going to multiply every single term by 2 times x minus 4. 2 times x minus 4 there, 2 times x minus 4 there, 2 times x minus 4 over here. 3 terms, 3 multiplications of 2 times x minus 4. And then when we clear, we cancel. Now I have to stop here and pick up in the next video.